29, once again, I'm reading in the dark, is that 10 cubed secant to the what?
6.
6. Both just x's?
Yeah.
Yes. All right. Oh. I got an idea.
Okay, I'm thinking we should leave
To the third.
10x sorry.
What's the derivative of the tangent?
Secant squared.
So I could certainly get a secant squared out of that, couldn't I?
Oh, yeah.
So I still am not sure that this will work. What would need to happen in order for this to work? Since the derivative of the tangent is secant squared x dx, I would need to be able to write everything else in there as tangents. Even power of secant will work. What are those formulas that change even powers of secant and tangent back and forth?
1 plus tan squared.
And if we just subtract 1 from both sides, right, we can change tan squareds to secant squareds and secant squareds to tan squareds with that one formula. That's really just one formula. So I'm going to rewrite this secant to the fourth as secant squared squared. Well, having done that, I'm going to rewrite this as tan cubed x. Secant squared we see is 1 plus tan squared, and then secant squared x dx. So let's let t equal tan x, then dt is secant squared x dx, and this now all becomes integral t cubed 1 plus t squared quantity squared dt, which is integral t cubed times t to the fourth plus 2t squared plus 1 dt, which is t to the 7 plus 2t to the 5 plus t to the 3 all dt. So 1/8 t to the 8 plus 2 over 6, 1/3 t to the 6 plus 1/4 t to the 4th plus an arbitrary constant. And why did I leave all that room in there where the t's are? I'm not going to leave it as t, am I? We're going to rewrite t as tan x.
Thanks.
And we're done. Is that okay?
I did it another way and I got another answer, but I think it's also right. Is that okay?
Well, let me ask you a question. Let's suppose that the answer to a problem were, suppose that we integrated some function, and upon finishing it, you found that the answer was this, plus an arbitrary constant. What if somebody else integrated that and they wrote this answer like so? Do they get full credit? They're the same thing, aren't they? And that's why you're seeing something different, because these trig functions all can be rewritten. I mean, after all, I can rewrite each one of these as a secant, can't I? And very likely that's what you did, is instead of filtering off as secant squared, yeah, here's another way of doing this problem. What was that, tan cubed? Secant to the
6.
secant to the 6. So So what I could have done here is rewritten this as tan squared, secant to the fifth, then factor out one tangent and one secant, and have secant x tan x dx. Well, since derivative of secant is secant x tan x dx, now what I'll do is I'll change tangent, tan squared, into secant squared. It's going to work just as well, isn't it? That's probably what you did. That's a valid answer. This is one of the more difficult tests for me to grade because sometimes the problem can be done in many different ways and have many different answers. And I have to read your work and give you credit for anything that you do that's valid. Question? You don't want me to finish that, do you?
No, no.
Okay.